Okay, so let's see what happens when I plug in infinity. So I have 1 plus 6 over infinity is 0. So I'll have 1 plus 0 to the infinity. 1 to the infinity. This is one that I need to do the longer, more intense version of taking a bold math step and then taking the ln of both sides, right? So first off, I have to let y equal 1 plus 6 over x to the x power. Then I'm going to take the ln of both sides, and then I'm going to do that so that this x will come down in the front. Okay, so now we're going to introduce the limit back in. So I have x times ln of 1 plus 6 over x. Okay, so this side I'm going to pause on. Just let it go, sit for a second. So now here, if I plug in infinity, I get infinity times ln of 1, which is 0. Infinity times 0, I have to put one of them in the denominator. This will almost always happen. So let's go put one of them in the denominator, not the ln, correct? Do not put the ln in the denominator. So let's move x to the denominator as 1 over x. So now when I put in infinity, I get ln of 1, which is 0, 1 over infinity, which is 0. So now let's use our L'Hopital's rule. Okay, so the derivative of ln of stuff is 1 over stuff times the derivative. Derivative of 1 is 0. The derivative of this will give me negative 6 over x squared, right? The derivative of 6 over x is the same thing as saying 6 times x to the negative 1. That's negative 6x to the negative 2, or negative 6 over x squared. Okay, so that's the numerator. The derivative of 1 over x will give me 1 over x squared. Okay, so let's cancel. So you can see these 1 over x squareds cancel. I'll have a 6 up there still, right? Oops, let me make a little more room. So I'll have a limit as x goes to infinity. So I'll have a negative 6 over a 1 plus 6 over x. Because the 1 over x squareds, the negative 1 over x squareds will cancel, and I'll just have this 6 up here. Oops, so it stays positive, right? But the negatives cancel even. Now plug in infinity. So if I plug in infinity, I get 6. 6 over infinity is 0 over 1. So pull in the left-hand side. So I get ln of y is equal to 6. So now our job is to find what's happening with the limit of y, so I'm going to take e of both sides. So e and ln cancel. So the limit of y is e to the 6th power. Okay, one more here. So if I plug in 0, I get 0 to the 0. So this is definitely one I'm going to have to do the ln on. So you're going to have to let y equal sine of x to the x power. Ln of y, ln of sine of x to the x. Take the time to put the limit back in and pull the x down in the front. Okay, so now I'm going to pause on this side. So here I have 0 times infinity. So you know never to put the ln in the denominator. So let's put the x in the denominator as 1 over x. So now it's infinity over infinity. Let's do L'Hopital's. So I get 1 over sine of x times cosine of x over negative 1 over x squared. So I'm going to multiply by the reciprocal. Oh, lost my positive sign there. So I'll get a negative x squared times cosine of x over a sine of x. So if I plug in 0, I get 0 over 0. So let's do L'Hopital's again. So first, d second plus second d first over cosine. So now if I plug in 0, I get 0 and 0 over 1. So 0 over 1 is 0. So what that means is the limit as x goes to 0 of ln of y is 0. So if I take the ln of both, take the e of both sides to get rid of the ln, I get e to the 0, which is 1.